All right, so let's see. Do I have everything going the way I needed to? Yes. Okay. So we had. So hopefully you've all had the chance to look over the videos I posted last week. I didn't post. In fact, I really only posted one batch of videos last week. So hopefully that was plenty of time for you to watch that. Um, so and we're in one of those frustrating situations where we have to learn more stuff because we have more stuff to learn for this course, but the exam is not going to cover the new stuff or much of the new stuff because we don't have that much time to ensure that it would be a fair test for you guys in that case. So your exam, which is this Friday, will basically, you saw it online. Somebody said I posted the wrong version, which I did, so I fixed that basically on Friday. So but the practice exam does cover primarily just method writing and coding. That's pretty much what the big portion of the exam is. So you've got a lot of reading, but you also have a lot of method writing, and those methods pretty much solely concern, manipulating arrays and manipulating strings. Yes?
So you would just take the practice exam when?
At your own convenience. The practice exam is taken at your own convenience. Useful for
like when did you change it?
Oh, basically as soon as I submitted it on Friday. So if it says 1068 on it, you've got the right practice exam.
Okay.
If you've got if it says data structures on it, then and it's completely unrecognizable, right? It was for the wrong class, so that was accidentally uploaded. I had the same file name, just in different folders, so not necessarily the smartest idea on my part. So what we are learning about now, though, and for the remainder of the semester, is objects. Now, as I mentioned, objects are basically a way to help us organize our code a bit more. And right now we're dealing with the objects on the most basic level that we have, which is writing classes and defining new types, essentially. Right? Previously, we'd been writing classes basically a self-contained program, right? Basically, you use it just like you would use something in C or in another language. They are essentially just programs that are self-contained, and you just write them. And then it just goes through the code and does all the things in it. The other thing but what Java's really meant for is for doing object-oriented programming, which is basically thinking about how to do these things in object format. And so we've been building this bomb example where basically what we wanted to do was draw all the points on a map, and the first way we knew how to do it was to build two arrays that had the x coordinates and y coordinates of each city, right? And that was a mess because then we have to keep track of two arrays. And so now what we've done is that we've created a point object, basically a point that represents, an object that represents a point on an x and y plane, right? Two-dimensional grid. So here and we define that we say it has basically a point has two variables. So this is essentially no more advanced than a struct if you're coming from C. Okay, this is essentially the only big thing is that they have to be defined in their own files, right? If you're coming from C. Now, objects are a bit more powerful than that, and we're going to get into that today. But for right now, well, it's pretty easy. You just list the components that they have that has an x and a y component, right? And then when you want to make it, you say, okay, I can make a new point, and I will set its x and y coordinates to be whatever I want it to be. Okay? And then I can pass them in like any object. So I'm passing in the point of the bomb. I'm passing in how big I want the bomb to be. I'm passing in the points, which is a list of points, which was created in another method, which was read cities. And then I pass in basically the panel to draw them on. Okay. And my reading a method basically just read from the file name. It read the file. Opened up the file, read it. It grabbed the first line from it. So let me just pull that up. So it was, where are you? I think it was, cities.txt. So we put first 6 on there, and then we had 4. Then we had just basically the list of x, y coordinates for a bunch of cities. Okay. And so then now we have to essentially draw them. So I had done that a bit, and then I had gone forward and realized that the video I was recording was A, it was getting a bit long, and B, it was getting a bit I didn't necessarily present it the right way when I was recording it. So, all right, point bomb. So here we wanted first draw all the cities, right? So for each point city in all the cities we have, right, which is an array of cities, right? So we have an array of point objects. What are point objects? They're x, y coordinates. So for each of those, we want to g dot draw oval, and we want to draw it. Let's see. Well, where do we want to draw these things? They are they have a radius, right? So let's say they're radius of 3. So they have a width of 6 and a height of 6. Oh, sorry, width of 6 and a height of 6. And then their xy coordinates are basically in the center of the circle should be basically let's see, city, right, because it's a city, dot x for its x coordinate, minus 3. Why? Because I'm saying they have a radius of 3. So, and remember with these things that we're drawing, the x and y coordinate, it's on the top, it's talking about the top left corner, right, of the circle or oval that this thing is in. So it's not, so the x and y coordinate doesn't give me the center, it just gives me the top left corner, which is why I'm doing this weird thing where I'm saying, hey, top left corner, well, that's 3 away from the center. City dot y, and the width and the height there. So right now I'll go ahead and run what we have. And we pop up a bunch of dots. And then, let's see, we probably want them to be filled up. So, so instead we change that to fill oval, right? And then we did g dot draw string. And we wanted, and let's see, we wanted city dot x plus, and this will just simply put the xy coordinates on the screen for each of these cities. Dot y, right? And that's how I just access these variables, right? They have an x and a y. They don't have a z because I didn't say it had a z, right? How does the program know that it has an x and y? Because those are the things I defined. Okay, and then the xy coordinates of where I want it displayed. City dot x. And then let's see how this looks. City dot y. And so now we've got our points in those locations, and some of them are overriding each other. And now, let's see, if we're drawing them, then basically, so we drew all the things first, then we set the color to red, and then basically we create the bomb down here. And then for all the cities, if their distance is further away, if their distance is not within the, if their distance is within the blast radius, as I explained in the previous videos, then we want to draw them red, so we draw them again. So first off, we're seeing a bit of repeated code here, right? We don't want to see a lot of repeated code, right? I just did a copy paste over here. So that's an indication that I could probably make a method out of that. So let's get into how objects, so what differentiates objects from structs in another programming language like C is the fact that you can also have methods built into these objects. Because I could create a method just to, do this whole drawing thing over here rather than doing the, what I did over there. So I could eliminate, the whole drawing thing by just creating a method out of it. Okay? And that's actually not a bad solution. In fact, if you're in a programming language that doesn't have objects, then this is the way to do it. I go, okay, public static void draw, this is my draw city method, take in the point city that I want to draw, right? And then the canvas I want to draw it on, so graphics G. Okay? And and then I'll copy paste this out, and I'll remove the, actually I'm going to remove that confusing bit of math over here. I'm just going to do that, fill oval, yeah, let's make the dot smaller, and we'll just simply put them in this location. Okay. Okay, and now I can do draw city and G over here. So for every single city so for every single city of all my cities, draw it, right? Then I set the color, and then for every city within the cities, get the distance from the bomb center in the X direction. Get the distance from the bomb center in the Y direction. Calculate that distance, and if that distance is less than the radius of the bomb, in other words, if it's within the bomb's blast radius, then redraw it because I want it to be drawn in red now, because that's what I set the canvas to, right? So this code looks a heck of a lot simpler now. The only issue is that so there's only one real issue with this, which is that with using the static method, essentially, if I wanted to use this point on in another program, right? Then first off, I have to pass along the point, right? Because if I'm writing this point object, I want to be able to reuse it as much as possible. Okay. So, okay, I have to pass along the point object. That's no problem. I just simply, kind of copy paste that Java file or import it. The other thing, though, that I have to do is that if I want to know how to draw it, I'd have to copy this along with it. I have to copy the static method along with it. And really, it'd be more convenient if this was grouped with this, program over here. That makes sense? If this was grouped with this over here, so I could just pass along the point object, so I don't have to, pass along two things. Not to mention that with the way we've been dealing, if you've seen we've been dealing with objects previously, like scanner, it doesn't work like read scanner and then the thing you want to use, right? It's scanner dot do something, right? Whenever we tell an object to do something, be it a string or a scanner, we've always done say the object dot do this, right? That's kind of the format we want to use. Now, there's nothing wrong with this format per se. It's just not what we do in Java. It's what you'll do in a bunch of other programming languages. But with Java, which makes it better to use where basically we can just make self-contained objects that know both what data they have and what they can do with the data. This is the format to use. And so what we can do is we can put a method inside the point object. So let's see what that looks like. So until now, we've been dealing purely with instance methods. We've been dealing with static methods up until this point. We've been dealing with static methods. Why do we know they're static methods? Because they have the word static in them. The methods that we're going to be dealing with now don't have the word static in them. And that just simply means that it's closely tied to the class that it's written in, right? Static methods, you can pretty much use them anywhere, right? Like math.square root, it doesn't really need a math object to make that, right? You just simply go math.square root and it works, right? You don't necessarily have to make a math object. And what would a math object even be, right? Sometimes it doesn't even make sense to do those. But right now we're going to be making instant methods. They go inside of a class and basically each object has its own method that works on itself. And they look like this. Public, then the return type, then the name of the method and all the parameters. So essentially just like a static method, only it doesn't have the word static. Okay? So here's their example. Public void shout. System.hello.println, hello there. So let's write that ourselves and see what that looks like. So this is where it starts differing a bit from if you've been doing structs. So public void shout. This is just basically a void method. It doesn't do anything. And it'll do system.println, hello there. Okay? And so now if we go into this class over here, let's see, we've created the bomb is a point, so we can use that as an example. I'll go ahead and delete my commented out one. And now let's go ahead and say the bomb, okay? And then if we hit dot, right, we can see that there's both the X and the Y, and with IntelliJ, which I've started using, the F I'm assuming means field over here, so it's got field, it's got X and Y, and it's got shout. It's got a bunch of other stuff over here as well. It's got like dot equals, dot to hash string, a bunch of stuff that if you notice doesn't actually exist in my code, right? We get into where this stuff comes from chapter 9, but for right now, the answer is to where's that stuff coming from? It's stuff Java writes for you for free. It just writes it automatically because they're super useful things to have. And Java just automatically writes you these a dot equals method, a dot notify, a dot wait, you know, a dot TwoString. Now, they won't really necessarily do anything useful, but they exist because they're so useful that we want to assume that any object you write has them. But we can basically say the bomb.shout, and then so we call this, and this specific object is going to run the code. So now notice it says hello there, right? Thinks it's Obi-Wan Kenobi or something. So, all right. So what we're going to do is that we're going to put that draw method inside of the graph of the we're going to put that draw method inside of the graphics. So now inside of the, oh wow, okay. I scrolled up on the mouse wheel apparently, okay. So we're going to now put the draw method inside of the object. Okay. So we're going to put that inside now. Public void draw, and all we need actually is what we're going to draw it on, graphics G. We don't need to pass in a point object to this thing, as I'll explain this in a bit. But now what I'll do is I'll take this code that I previously written over here, and I will just simply go X and Y, draw X, all right, so that compiles oddly enough. So first off, where's X and Y coming from? Come on, you see it. Where's X and Y? They're up top, over here. That's where it's getting it from. But I didn't define them over here, right? But what it's saying is that, so what this is it's called an instance method. So each instance of this object, basically each individual object that we create, we call that an instance of an object. Each individual object that we create that's a point, it has an X and a Y, and it has this draw method. And it knows basically that, and each object basically knows its own data. Now, and it says, okay, so if this method is called and I get past the graphics, then I want to take my X and my Y coordinates and put a dot there. That's 3 by 3, and then I want to draw, my, I want to draw a string there. I want to draw basically a label there that I can put. Plus X, and then let's go ahead and put them in a bit more of a, okay. And now if we go over here to the bomb class, we can do city.draw G, and this is just to show you that it works. And then I'm going to start really explaining, kind of how did something look that simple, or fairly, it wasn't very verbose like we had earlier. And how does that work? But it does work now. All right, so what this is that this is an instance method. And what it's saying is that it's when each point gets called, when each point calls its draw method, it says, okay, I want to draw an oval at my X and my Y. How does it know it's what my x and my y is? Well, we defined it. We defined a different value for each object, right? Each object has its own x and y coordinate. It's not going to get it confused with the other x and y coordinates because each point has its own copy, right? That makes sense to everybody? Each object has its own x and y coordinate. And so when we tell it to draw its own x and y coordinate, it fills in an x and a y coordinate at this location, and then it says to draw a string at this location. What they often say is that basically that so kind of each object has its own copy of the draw method, and each object has its own data. So if you've got one that's at 7,2, right? This first point object is gonna have 7 for x and then 2 for y, and then it has its own draw method, and it only sees its x and y values. And then point 2 has 4 and 3 as its x and y coordinates, and it can only see its 4 and it only see its 3. So it's not going to get confused about whose whose data it has, right? Just like speaking to everybody in this room, everybody can type on the key on a keyboard, right? Every person has their own name. You're not going to get confused about what your own name is, right? And when I tell you to type a name in front of a keyboard, well, you're going to look at the keyboard in front of you, and you're not going to put down somebody else's name because you know what your name is, and you're not going to get confused with anybody else's. What they often say is that this is an implicit parameter, that basically that whenever you have an instant method, the object itself is kind of passed along as an implicit parameter. It's implied that basically the object knows everything about itself. There's two basic kinds of. So there's also just two basic kinds of methods that are basic, that are so basic that actually your program will write them for you automatically. Now their formal names I hate because they're stupid and long. There's Accessor and Mutator, which sound like, how in the world would you remember them? But accessors, basically, they let another program look at the object and say, okay, what's this data? What's this data? Can you return this value? Essentially, it says, give me this information. So distance from origin. I'm going to go with an even simpler one. Get x, which would give me the x value. It's a function that returns the x value. And then there's mutators, which modify the object state. In other words, it changes what the object's at. I hate these names, Accessor and Mutator. Honestly, I prefer them with the easier name. Getter, which means that basically you get, and this is what Eclipse calls them, getters. So those get data from an object, and setters, which set data from an object. Much easier to remember than Accessor and Mutator. But those are apparently the formal names. But these are so common. Yeah, Accessor and Mutator. But what I'm saying is that these are so common that your IDE can actually pretty much write the code for you. Okay? So I'll write one just to show you first, and then I'll have the IDE write one for me automatically. Public. Public int get x, right? It even started suggesting the name for me. Return x. And this will basically, if I call this, it will return the x value. Now you may think this is completely useless because you could just system.out the print line point.x, right? You could do that, but later on what we're going to see is that we're going to eventually, as we move along later in this lecture, we're eventually going to add something over here that says a modifier over here, private, which means actually, please, you can't do that. You can only interact with the get method. Okay, but this is such a simple method and such a common method that's written that I can hit a key command and it says generate a constructor getter and setter, right? So it doesn't even use the access and mutator; it calls them getter and setters. So I'll write a getter, and it says, okay, you already have a get x. Obviously, the only one left to write is a get y. Hit enter. It automatic, and you see that it wrote the code for me. These are such common things that it can write that. It writes it for me. Now, depending on your IDE, you might have to go over here into code or something, right? Override method generate, right? For me, it was generate. But it just depends on your IDE. NetBeans has it, Eclipse has it. Okay. So those are getters. And essentially what we could do here is that we could go to, let's not run the boom method, so we're not going to draw anything right now. We can run over here to point, new point, the bomb dot get x. Let's go ahead and now if I run it, it will print out the drawing panel, and it prints out 100 down here because that is the x coordinate, right? So that's a very simple method. And what it's doing is that, remember, where's it getting the x from? Well, IDEs are kind enough that if you highlight it, it will go, aha, you've got an x over here. That's where we're getting the x from. Okay, so let's go ahead and write a setter method. Setter methods typically do one parameter at a time, but we'll start out by doing two because maybe we want to set the location. Public void set location int new x int new y. And for right now, we don't want to give them the same names, right? But we'll say, okay, we'll set x to be the new x, and now y will be the new y. And what's very fascinating over here is because these, right, new x and new y, they only exist inside this method, right? Because they're local variables, right? But x and y over here, these guys, notice that they're highlighted a different color. If you try that in your IDE, they'll be highlighted a different color too. They're instance variables is what they're called. In other words, they exist so long as this object exists. That makes sense, right? They exist, x and y exist so long as the point exists, right? That makes sense because if they stopped existing, that would be a bit of an issue if you wanted to do anything with them. So x and y exist for as long as the point exists. So if you change the x and y value here, they'll change. So here I've got the point set up for the bomb.x is equal to 100, the bomb.x, the y is 150. I can now do the bomb. I can now, skip all this stuff and say the bomb dot set location is equal to, let's say, at 75, 75. And now if I run it, changes the location to 75, 75, which hits all my cities. If I say 375, 75, so now, again, the code's starting to clean up, right? It's only, and these, again, these are things basically that I can just use them without having to pass in other stuff. I don't have to, all the stuff that I need to use with a point is inside the point method. Okay? So now what about a translate method that changes the location by x and y amount? Well, that simply just generates, that just simply changes my location. So public void. Notice that these are void methods because there's really nothing to return here. I'm changing the internal state of the method. So translate int dx, right? The delta x, or difference in x, int delta y. So then again, that's just delta is just simply a fancy way of saying difference that makes you sound smarter. Swear that's the entire reason physicists do it. So now we'll say x is equal to x plus dx. So x is the new x coordinate is equal to x plus the change in x, and then y is equal to the x plus the change in y. Oh. So now if I do this over here in the bomb method, if I call this, so now I can say the bomb dot translate. The bomb dot translate. Let's say I want to move it -100 over and 50 more down than our last time. So now, as you can see, it's further to the left and further down than last time I dropped it. Okay. All right. So alternative solution that uses alternative solution we could have had translate call set location, but honestly that's a bit more to get your head wrapped around than you need to right now. So there's other things we can do. Right? We have this distance calculation over here in the bomb class, right? And that seems a useful thing for points to be able to do, right? So maybe we should throw that into the point. So given this point object, tell me the distance from it to another point. So public double distance point other point, right? So to tell the difference between 2 points, you need 2 points, right? So we have first this point, right? The one that's being called, that we're calling, right? And then we have the other point, which will be passed as a parameter. So the distance is, so now what do we figure out? We say int delta x, the difference in x is equal to x minus the other point, or is it other point minus, x minus the other point's x? Or is it other point x minus x? Doesn't matter for distance. It really doesn't, because you're going to be squaring those anyway, right? So it's essentially you're going to be getting the absolute value. One of these is going to be bigger than the other. And then int dy is equal to y minus other point dot y. So we get the dx, we get the dy, we get the difference in x, we get the difference in y, and then the int distance. Now remember, all these local variables I'm creating over here, they're local. They're going to go away at the end of the distance method. But the x and y remains for as long as the point object remains. So distance is equal to, right, and the distance for Euclidean distances, it's the square root, oh, here we go, double distance is equal to the math.square root of, I believe it's x, the dx is squared, right, the difference in x is squared, so dx times dx plus dy times dy, right? The square root of the distance is squared. That's to go back to, some of the math courses, but, I'm not going to, when you get stuff like this, you're going to, so I like using geometry when I do give you, points, but as you may have seen in the Pentagon assignment that I handed out, which hopefully by the end of Wednesday you should be able to see that's not actually a hard thing to do, I give you the form, whenever you have to deal with something, I'm not going to rely on you trying to remember a formula from geometry or something. I'll give you those formulas. So, turn distance. I don't have time to teach you geometry. So now we can go over here, and we can now, again, simplify over here. So for each point in the city, if the distance, so now for each city, if city dot distance to the bomb is less than the radius, draw it in red, right? So now the code in the boom method that was looking huge and giant and had so much code in it, right? We're slowly just pushing all this stuff out into the point method, and so now it looks a lot easier to write over here. It's a lot simpler, right? If the city's distance to the bomb is less than the radius, draw the city. Again, this time in red. So everybody's seeing how basically this is simplifying our code, even though it does feel like a bit that we're modifying our code a bit, or making it a bit, bigger. All right. So as I mentioned earlier, there's one other thing that we want to do, right? I think I showed you earlier, is that we wanted to know how well our, you're writing our points, and we want to say, hey, okay, I want to print out, my BOM object to see what it looks like, right? The data inside of it. And if you try printing out an object, it generally prints out a bunch of gibberish like this. Objects.point, objects being the package I'm in, and then point being the thing I'm trying to print out. And then it gives you at 55B7A4 E0, which I've said is a memory location, basically where it resides in memory, right? And what this is that this goes back to basically the idea that that Java by default doesn't really know how you want to print your object. It's possible your object doesn't even have a field in it, right? So what should it print out? What we'd like to, so that's typically what's going to print out is something like this, right? You create a new point, you set the x and y, and then you print out and say p is point at a memory location. Better data would come from saying p is, p.x and then p.y, but that means you'd have to know all the stuff in the point. What if there was a z-coordinate, right? A potential z-coordinate for a potential third dimension that you might not be using. What we really would like to do is say p is and then plus p, right? So every object, as I mentioned, comes with a bunch of other methods built into it, and one of them is called TwoString, right? It's such an important method that basically we need to be able, basically printing out an object is such an important thing, and strings are so important, we need to know how to convert any object into a string. And if you don't tell me how, I need to have an automatic way of doing so. And so my automatic way of doing so, if you don't tell me how to print out this object, is that I'm going to print it out by saying what its name is and its memory location, right? Every class has a TwoString, even if it's not your code, right? Even if you don't write a TwoString method, you're going to have one. It's automatically going to be generated. And what's going to do is it's going to say it's the class name at this location. So what really happens is that when I call a method like this over here, print line the BOM, what happens is that we are actually doing this. It's automatically adding you want it converted to a string? I'll convert it to a string automatically. Right? It's just one of those things that Java does under the hood to make things simpler when you're starting out. Okay, but it still prints out this objects at point stuff, and we need to change that. So to change that, we need to add in a TwoString method. So now, let's start him right. So public string TwoString, right? And this is because that each point gets a copy of this method. So let's go ahead and return foo. Okay. So let's go ahead and run it, and now instead of printing out the memory location, it prints out foo. Okay, so now when we draw each of these cities, why don't we print it out as well to just get some information. So for each of these city points, let's print it out, and they all printed out foo. So that's not too useful because, of course, everything is printing out the same thing. So instead, generally, you want to print out some data actually about your object. So in here, maybe I'll return instead as the string, what we've been trying to draw, which is x plus, so that plus x, then plus a comma, plus a y, plus, the end curly brace. And now if we run the BOM class, what do we get? Each of these things now prints out its own x and y coordinates. Now, how did it know to print out its own? Well, remember, each point gets its own copy of TwoString, and its x and y, it uses, it knows what its own x and y coordinates are, right? So it doesn't have to try to keep them straight and not confuse them with the other ones. All right. So last thing is, before we move on to before we're done with the basics of this stuff, is constructors, which is the last bit of code that we automatically generated. How do we create a new point object? Well, we said point the bomb is equal to a new point, right? And then we had to set its location up, right, in another method call, right? So it would be much easier. If instead we could just, do it all in one. Like scanner, right? When you write a scanner, we don't have to do, scanner file reader is equal to a new scanner with nothing in it, and then go file reader dot source is equal to, something else. Instead, what we do is we say scanner file reader is equal to new scanner, and then we tell it all the necessary data that it needs to build itself. This is called a constructor, right? To create a new point, we need three things. We need three lines right now. We need the thing that actually creates the point, and then we have to set up the x, and then we have to set up the y. Even if we use the set location method, that just simply gives us 2 lines instead. Rather, we'd have it'd be cooler if we could do one of these. So what we can do. So finally, the last thing that's really, so this is like the third part of our of objects, right? So the first part is so we can split up a class into 3 parts, right? You've got your instance variables, right? And you might have some other variables up here too, as we'll learn when we learn about the difference between instance variables and static variables, right? You've also got your instance methods, right? And then finally, we're going to learn about one last thing, constructors. Okay? So constructors are the final part, and they look like this. Basically, they tell you how to it tells Java how to set up the object. And if you don't include one, Java automatically writes one for you. And what it writes looks like this: public point. So it kind of looks like it kind of looks like a method, only it has no return type, and the name of the constructor is that it's the same name as the class. Public point, and then it says, okay, all the other, and then it leaves it blank. That's what Java does for you automatically. If you don't have anything, it just creates this automatically for you. And what it does is simply says set everything to null or 0, right? So by default, your x and y coordinates are set to 0. So we can set that up manually. X is equal to 0, y is equal to 0. And notice it's changed nothing about our code. It doesn't change. It doesn't work any differently, right? It just is now. It's working the same. I've only just simply spelled out what Java was doing automatically. But what's cool about constructors is that you can have more than one. You can have more than one way of building it, right? Here we had, like with scanner, you can tell it to take in either a file, or you can tell it to take in a stream, like system.in. So there's more than one ways to build this. So we can also tell it to say, hey, public point, and take in parameters just like a method. Int start x, int start y, and now what we can do, don't put that semicolon there, is we can say x is equal to the start x, y is equal to the start y, and of course this doesn't change anything because I'm not using it now, but now I have the option of doing this. Right, where I have points.I is equal to new point, I can now say each of the points is now an x, uses those x and y coordinates. And now when I run it, again, we've just simplified our code even more. When we create our bomb down here, I don't have to do this anymore. I can simply say the bomb, its starting location is at 100, 100. And I can run it, And it's more than happy to put it in that location. So that's why I said to set it up as. So constructors let you set up basically anything you need at the beginning of it. And again, if you don't provide one, then Java will provide one automatically. The constructor is what gets called when you call the new keyword, right? That's what you use that's how you call it. You say new point. And there's no return type because what it's implicitly doing is that it's returning the new object that you just created. It implicitly does that, right? And we don't put a return type there because we don't want to get it confused with the method. That's actually the real big reason. We want you to know that it's a new thing. So here's their example. They just used initial x and initial y instead of start x, start y. Right? So what happens to this when the following call is made? What happens over here is that when you do point 1 is equal to new point, 7, 2, 7 gets copied over to here, 2 gets copied over here, then 7 from initial x gets copied in x, and the 2 from initial y gets copied in y. So you can have multiple constructors, as I've just shown you. The default is, and it's always nice to have a default value, just simply to set something up quickly. So a common bug that is done with constructors is when you redeclare your fields as local variables. And this is called shadowing. Essentially here's the bug, right? If I do int x over here, notice how the color changed. And I'm just going to change the x. And now I'm going to run bomb. Notice how all the points are at 0. Now, why is that? Well, I created a new variable called x, a new local variable called x, right? And I said take start x and set it to a new local variable called int x, and then take the local variable start y and set it into the instance variable y. So everything got a y coordinate, but not an x coordinate. So this is kind of dangerous. You got to keep your instance variables and your other variables straight. Your instance variables and your local variables. And I'll give you a hint of how to do that. There's something I do later. And the other thing that's a common mistake is you accidentally put void over here. That makes it a method, not a constructor, so it's not going to get called when you return. So remember, constructors have no return thing. All right, so that's how we write objects. So let's go ahead and start by making a, kind of a new object. We're going to work on a new object after this, but right now we're going to learn about encapsulation. Okay, so I mentioned, like in the first video, that there's I think I mentioned in the first video, there's 3 things you need in order to be considered a object-oriented programming language. Okay, the first, and they're encapsulation, inheritance, and polymorphism. 2 of which sound like they're just completely obtuse words that we just made up simply to torture you. This may be partially correct. But, inheritance, that's a word that you're familiar with. Encapsulation and polymorphism. But fortunately for you, inheritance and polymorphism, they got moved to another chapter, so they're their own beasts. So we're going to, and they're not really hard, they just have a really hard word. But encapsulation is basically this, it's a hard idea it's not exactly a hard idea to explain, but it's not as complicated as it sounds, as like the word like encapsulation would imply. The idea of encapsulation is that we're hiding our implementation details from our clients. Basically, when we write code, we want to make it as easy for people to write. And let me show you what I mean. We do it all the time. Okay. Over here, in fact. Do you know how math.square root works? Anybody? Well, the comments for math.square root says it tells me what it does, right? Math.square root tells me what it does. It tells me that it returns the correctly rounded positive square root of a double. Special cases, if it's not a number or less than 0, it's not a number. Otherwise, it returns the double value closest to the true mathematical square root of the argument. How does it do that? I don't know. Probably Newton's method, which is like an approximation. Square roots are hard to figure out. I mean, do you even know by hand how to figure out what the square root of something is? Like, that's not, a perfect square? Don't know. If I have to do that, I use something called Newton's method to approximate it, which just simply means I estimate it. I estimate the square root a lot of the time. But when you hit the square root button on a calculator or on this, you don't need to know how it works, right? You just need to know that it does work. Okay? Similarly, when you get into the car and turn on the engine, either by turning the key or pressing a button in a bunch of the newer cars these days, do you know what processes happen within this, all within a second of turning the key that that ignites things and starts pumping fuel and gets the engine moving? Do you know any of the mechanics that go into that? Maybe yeah, some of you if you're really into cars, but I certainly don't. I freely admit my ignorance when it comes to cars. I have no idea. All I know is that when I put key in and turn it, car turns on and I can go. It is. I don't need to be an expert to know how to use the car. I don't need to know how power steering works to appreciate that it exists. I don't need to know how basically anything works when I hit the brakes. I just simply need to know when I hit the pedal, my car slows down. The brake pedal specifically. It'd be bad if it was the acceleration pedal. So this is the idea of encapsulation. The idea is that it separates what you do with it from how it works, right? When you have a phone, you don't need to know how hitting the buttons on your screen changes anything. You don't need to know what goes on with the circuitry in there. You just need to know that if you hit button, it does something. And so the idea here is that we're going to use the same kind of thing here. When we give people our programs, our classes, we don't want to make them too complex. We're going to hide details from them. And we're going to do that by using a keyword called private. Now, some of you, if you're not too tired, that should set off like, wait a second, there's a public and there's a private, so they're probably opposites of each other. So let's go ahead and write basically an object that I really like. I'll go ahead and start writing a circle method. A object that will represent a circle. I'm not going to draw it. I might do drawing with it yet, but for right now, let's just simply use the circle class as an example object that we can write, because I like working with geometrical shapes to begin with. Okay, public class circle. Now, circles are defined by one field and one piece of data alone, essentially. Well, maybe 3 if we care about drawing them. The first is the radius, right? And then the other 2, if we care about where it's going to go, it would be a double x coordinate and a double, well, let's just simply assume we're in an integer plane, so int x and int y for its location. So circles are fairly easy. Now, the idea here is that if they're not private, essentially if they're not private, I can mess with them any way I want. So let me create a new class, circle test, and then one more object to kind of get the point across. Java bank account. Okay? So circle test, public static void main. Right, circle C is equal to a new circle, right? I didn't generate a constructor for it, but Java automatically writes one for me. And I can go C.radius is equal to, whatever, 5. That doesn't seem too, exciting or anything, or that doesn't seem to have nefarious implications. But say I've got something like a bank account, right, over here, and I say double balance, right? And here I create a new bank account. So bank account B is equal to new bank account. B dot balance is so say I'm just somebody who's got access to the bank account object because I'm working with bank accounts and maybe I'm trying to sum up them. All I'm trying to do is sum up them, and I notice, wait a second, my name is in there. That's my bank account. B dot balance. Can I access the balance? Oh, cool. B dot balance is equal to, let's just make this really big, right? So this is an example basically of why you probably want to keep things private, right? Or I could be looking through other people's bank accounts, right? And I can go, print out your bank account balance just like that if it's not private. So what we can do to prevent basically people from getting into stuff that we don't want them to necessarily see is put the word private in front of it. And now if we go back over here, it's going to generate errors. It says, hey, you can't print that out. It's private. It won't compile. B.balance is equal to a bunch of money. You can't set that. It's private. You can't change it. Or sorry, you can't change it. The bank account program, though, can. So private prevents any clients, anybody who's creating objects, from doing that, right? So here, like if I set x and y in our point object to private, it wouldn't, they wouldn't be able to change it or read it. And in that case, that's when you would want to use a getter and setter, right? So say you want somebody to be able to read the value. Maybe you want somebody to read the value but not change the value, right? What you'd do is you'd make your object, you'd make the bank account, say, private, and then you'd have like a method that says get bank account, but you wouldn't have a set bank account. So you could read it, but you can't write it. That makes sense? So let's go ahead and change our class a bit. So let's go ahead and do private int x, private int y for the point class. And I promise I'll get to the circle class. That's going to be used for doing a bunch of other stuff too. So now we can't do city.x over here. We have to do city.getx, city.getY, which is a bit more tedious. But fortunately, the predictor is very good at figuring out what you want. And actually, over here in the drawstring, I can use city. I can just use city. Just print out the TwoString. And then where else do I have it? I have bomb.getx, bomb.getY. Really hope this isn't getting me onto like a watch list or something. And so now the benefit here is that basically you can look at the methods now and just see what can we do with this object just from the methods, right? You don't have to worry about the internal state. You don't have to worry about the internal x and y. You just simply know what you can do with the x and with the program simply looking at the methods. Yeah, so it also protects people from unwanted access, right? You can't increase a account balance fraudulently, or prevents one way of doing that. We can change the implementation later, right? For instance, we could use we can rewrite it so it's got radians and degrees. Radius and degrees for polar coordinates. It also allows you to put enforcements on valid values, like you can only allow accounts with non-negative balances. You can only accept dates with a month 1 through 12. Let's see. What else is there? So the this keyword was the next slide. This keyword. So it refers to something inside your class. So this is particularly is a very powerful tool, and I like it a lot. So remember how I was talking about like the common problem is somebody doing int x and int y over here in a constructor, and that generates a problem, and that's an issue, right? You've got an x and y, and that can be an issue. So how do you prevent that? Well, or even worse, okay? What if I generate my generate my method over here, my constructor over here, sorry, and I pass in an x and a y that have the same names as the values over here. You've got x and x and y and y. How can I tell the difference between them, right? We've got the local variables over here and the instance variables up there, right? How do we tell the difference between them? Or how can I make sure, explicitly sure, so there's no confusion because I am a sloppy programmer, that I don't accidentally shadow my code like this? Well, there's a special keyword. Now, if you've taken Python, this is the self keyword or the self word. But in Java, it's called this. Now, this means this object, right? This specific copy of the code, right? This guy who's being created, this guy who you're calling get x on, this guy who you're calling get y on, this guy who you're doing translate on, this object. So this means this object. So this dot x means this object's x coordinate is equal to the x value you just passed in. This dot y is equal to the y value you passed in. Now you don't necessarily, and notice how basically it changed the color from gray to red as soon as I just added this keyword to indicate that that we're working with the instance variable. This allows us to, I like using this a lot because it lets me know that I'm working with this object's fields. So x is equal to new x. This dot y is equal to new y. And you don't always need it, right? I just like using it. But the advantage here is that basically you can give everything the same name, right? You can go, and then it becomes much easier to match stuff up, right? You can go, this dot x is equal to x, right? These two go together, and this dot y is equal to y. Much harder to make a mistake as to putting one with the other accidentally. We can also use this to refer to call a method or to call a constructor, which we'll see. So, and this keyword prevents us from a lot. It allows us to do this, right? It allows us to shadow now. It allows us to do that fine and still access our variables. So right over here we have set location x and y. We have the local variable x and y, and we have the instance variable x and y, right? How do I know which is which? Well, local variables are the most specific ones, so so if you're just saying x and y, it's going to refer to the local variables. But how do I get to the instance variables? I use the this keyword. All right. So with that in mind, I think we have enough to create our so what encapsulation essentially means, though, in practice, is that we're going to make our variables private and almost all of our methods public, and only use the methods that we need. So here, I'm going to start by writing a circle class. Private double radius, private x int x, private int y. Right? So those are basically the things about a circle. Now let's work on our constructors. I wonder if I can automatically generate constructors as well. They're extremely, as you may have noticed, they're extremely easy to write, so I'm just simply going to, oh, look, constructors, the first item on the list. Let's just create a constructor that just builds the radius. And look what it wrote. Public circle, so this is the code to create a new circle, taken a radius, if it takes in a radius, it takes in a radius, and it says this dot radius is equal to radius. So the whole using this keyword to keep the local variable and the instance variable separate like that, and giving the local variables and the instance variables the same name, that's pretty much the way it works. And let's go ahead and write another. Let's go ahead and write another constructor. Just what should the default radius of a circle be if I don't provide a if I don't provide any information? Circle. So if I don't provide any information, let's say the radius of it is 0. So I could do this dot radius is equal to 0, but that's boring. Instead, what I can, and also not nearly lazy enough, I can actually be very lazy and call the other constructor by using this and then passing in 0. And what that does is that it calls the other constructor and it says, I'm being lazy, just complete this code using the 0 passed in there. We'll see more examples of this later. And honestly, I don't use this much, but the slides mentioned it, and I wanted to make sure you saw that existed. Okay. Now let's continue with writing a circle. Now that we can actually make one. Now that we can make a circle, let's go ahead and what can we do with one? Well, circles, right? You can generate. Well, obviously, we want to return the radius, so public. Public, not static, right? Public double get radius. Oh, automatically wrote that for me. Return radius. There we go. What other things are there about circles? Essentially, there's two equations you've learned at some point, right? Area and you've learned about the area, how to generate the area of the circle and the circumference and the diameter, right? So public double get diameter. We don't need to store any of those, by the way, because they all work off of using the radius. So we don't need a diameter field, right? We can just generate the diameter by returning this dot radius times 2, right? The diameter is twice the radius, right? So that will give us the so that creates the radius. What's the equation for the circumference of a circle? Anybody remember? And did I spell circumference? No, it says just it's never used. What's the circumference of a circle? Come on, this is easy geometry. 2 pi r. Thank you. So we can pretty much do that. 2 times pi times r. Oh. So radius over here instead of r because because we don't have to be limited to using a single letter, right, for our variables. So 2 times 5 times the radius. We don't have a pi variable up. We could use math.pi, but for an example I want to use next class, let's create a variable pi. Okay? So first things, let's put double pi up here. And this actually gets us into a couple of really good examples of why sometimes you want to make stuff private, sometimes you want to make stuff public, but also why some other things that I showed you earlier exist. Like, so we've got this circle here that we're creating. So we're going to create a circle. Let's set its radius equal to 7, right? But now we know it has a pi. Circle dot pi is equal to 4. So it's private, so I can't change it, but I can't really use it outside. If I want classes out on the outside to be able to use it, use the pi variable I have set up. Then I want to be able to. Then I should probably do this. So now I can go system.out.println c.pi. Okay, and pi is going to be equal to 0 because I didn't set up any value for pi. Now, it seems a bit annoying that I'd have to set up pi in every single one of these constructors, but if I know what the variable is going to be by default, I can set it up over here. Public double pi is equal to 3.14159, right? So I can set up the variable up there for pi. You don't generally do this except for what's going to happen next. So there. But the issue is, of course, I can change the value of pi. Somebody could go into my circle and say, hey, they could accidentally do pi is equal to 5, right? And now that changes this circle's value for pi, right? Because it's not private, right? It's public, meaning anybody can see it. Private means only I can see it. I being this class. But we did learn about one other keyword, right? Which meant if I set something up, I don't want it to be changed. Can you think back all the way? Sorry? Final. So I can say public final double pi. And now it says, hey, you can't change that. Right? So now we actually, so this is why you would ever set it up this way. Because remember, once we set this value up, we can't change it. Not even in here. I can't go this object's pi value is equal to 3. Yeah, I can't do that. So another type of variable you can have over here that you can make constants over here. Okay, now typically you actually have one more keyword in there, but I'll get into that. I like to show why that keyword exists too. So now we have a 2 times pi times the radius. Notice I didn't use this keyword here. That's fine. And we have an area. And the circles also have an area method as well. Public double get area. Right? Return 2. What's the area equation again? Pi squared. Yeah. So pi times radius times the radius. Right? And this is essentially all the stuff you need for a circle, right? You've got, basically you can create a circle object, you can get the diameter of the circle, you can get the circumference, you can get the area. That's essentially a lot of what you need for the circle, for basic stuff, right? This models that shape pretty well. So, so it's a pretty good, it's a pretty good system there. And so now I can create a circle with a radius 7, and I can ask, hey, circle, what is the circle.getCircumference? What's the circumference of a circle with a radius of 7? It's 43.98. C.getArea, 153. So it gets objects aren't really that hard to write. They're pretty straightforward to write. You figure out what the instance variables for that particular object are, and what the methods are. And what we'll find out is that essentially what we're going to eventually do is we're going to work with basically some simple objects at first, like using a object to model a game of tic-tac-toe. Okay, nothing too bad. Then the next one is going to be the game of life, and then hopefully the last one, I plan on giving you a massive project that's actually already written for you, and you just have to make an adjustment to one class. But it's a way for you to see how you can use a lot of different objects to interact with each other. So it's 12:14. I think I've got into an excellent stopping point, and most of you seem pretty tired for some reason. I don't know why. You guys didn't get to sleep at 3 in the morning, so maybe some of you did. But all right, so I think that's good for today. So I will be there for office hours today.